Hello, we are
Maciej and
Maciej and Roman,
yeah,
and this is our code for assignment 2 for computer applications in power systems. The main purpose of the code is to get a set of data from an SQL database, and then using that data of a power system, which is composed of 9 buses, we are clustering the data to identify in what state is the system running in each cluster. So for this, first we will show you how the program runs. We have here some notes about the colors and what do they mean. And then using the data, we are clustering using the k-means method first. And we can see it here in the graph that, for example, blue cluster corresponds to disconnection of a line for maintenance. Red cluster corresponds to high load rate during peak hours, which is here, yeah. We are printing, by the way, the 9 buses of the system. And we can see all of them here. We can see also that the bus number 1 doesn't show anything because it's always 1. The voltage is always 1 with an angle of 0 since this is the slack bus. The yellow cluster then is the shutdown for generators for maintenance, and the green cluster corresponds to low load rate during night. We can see that during low load we have high voltage in most of the nodes, in all of them. We can see also that the red one, which corresponds to high load, is the one with the lowest voltage in all the nodes as well, which makes sense since when we are demanding more power, the current is greater, and greater currents cause greater voltage drops. Okay, so this cluster was done using the learning samples
and using the k-means algorithm.
Exactly. So after that, we use the KNN method to cluster also the test samples. We can show it here. And also, we tested and compared the KNN results with the k-means results for the test set, and we found that 20 out of 20 samples were clustered in the same way by both methods.
Yeah, and finally we also printed out the cluster of every sample in our learning set and in our data set, test set. So yeah, that's also a convenient way to see it. And now we're gonna explain how our code works. So as you can see, we have a couple of classes. There's the main class in which the main code is situated. We also have the SQL database class in which we import things from the database. And yeah, the other important ones are sample and class sample. So this is a class holding a constructor for our samples before we actually cluster them. So we have the time and values. So we have 18 values for 9 voltages, 9 angles. And in the class sample, this class inherits time and values from the previous one, but additionally it has the distance and distances to every centroid. It's used for internal purposes, and it also has the cluster number. So this is the actual constructor for holding cluster samples. In this method, in this class, we are holding a method for importing samples from the database. So yeah, we set up the connection, and then it's pretty much as in the first assignment. So we are selecting things from the database, and we also order them by time and by name, both ascending. So it also makes things easier for us later on. And yeah, here we have a couple of if statements to actually distinguish between buses. And what's the goal of this method? It's to create objects in the sample class in which we add all the angles and voltages, starting from voltage at bus 1, then bus 2 until bus 9, and then all angles from angle 1 to angle 9. Yeah, and in the main file, we first create a couple of array lists that we use later on. And first we start from getting best fit centroid. That's the essence of our code, because in this function we basically where is this function?
I think it was
This before? Okay, it's somewhere there, but in this function the goal is to make ourselves sure that we end up having a centroid in every cluster, because there's 4 clusters. Yeah, it's here, and we want to make sure that we have centroids in every of them, because it could happen that we have like 4 centroids in just one cluster, and then the whole code would not work out really well. So in this method we use 2 other methods. It will just create random centroids. We simply create 4 random centroids, and then we want to get the average distance from the sample to its assigned centroid. And by looking at the average distance, we can know that the best fit centroids will have the smallest distance. So let me quickly show you the method. Okay, it's gonna be here. So in this method, as I said, we are going to return the average distance from our centroids to samples. So we have a while loop which runs until we have either 100 iterations or the difference. It runs until the difference is smaller than this threshold, which is quite a small difference. And yeah, we keep doing new centroids, and we keep using Euclidean distance to calculate the distance between the sample and the centroid. And if the distance is smaller than the previous iteration distance, then we simply store it as the best fit centroid for now. And we keep doing this until we reach the smallest distance. And we also keep reassigning centroids, as it is explained in our report.
Yeah, all of this is following the k-means algorithm.
Yeah, exactly. And when this is done, so we indeed have the best fit centroids, we can actually start doing our main job, which is cluster samples using k-means first. So this is done on the learning set. This function is exactly the same as the function to get the average distance, only that we return the array list of clustered samples. And then my friend will explain about plotting things later on. And we also use the KNN clustering algorithm to cluster samples using KN on the test set. And then we have a function called test KNN, where we compare cluster samples using KNN and cluster test samples using k-means, and we just want to see how many of them are correct. Yeah, and then we have the GUI part, and okay. And yeah, I'm gonna go super quickly through the KNN. Yeah, it's here. So yeah, we have the query, which is the new sample. So we have 20 queries in total, and we simply keep looping through all the samples in the cluster samples array list, and we keep calculating the distance from the query sample to all of them. Then we, having obtained an array list like the result list, we sort it by the smallest distance ascending, and we just pick the k nearest, like for instance 2 or 3 nearest ones, and the cluster with the highest frequency is the cluster that is being assigned to the particular sample. And in the test function, we simply we could just compare the cluster from the KNN is the same as the cluster in the k-means, and if it is, then the result is correct. And as you could see, we have 20 out of 20 correct. Yeah, now Roman will go quickly through the...
Yeah, and finally, this is the method that we use to assign the cluster names. In this method, we were just using some power system analysis knowledge to identify which cluster was corresponding to each one of the names that we were given by the assignment. For example, we were comparing the mean difference between buses. This means that we were comparing the voltage difference between the generation buses and the adjacent buses just to check if there was a voltage difference, and if it was not a voltage difference or not a big one, it means that there is no current flowing through this line. And if there's no current, then we can say that there's disconnection, there's a shutdown of generator for maintenance, because if the generation buses are just generation, are purely generators, and they doesn't have a load, then disconnecting the generator will cause that there is no current between this bus and the adjacent one, and it just have one adjacent bus. So if there's no current, then the voltage in both buses should be the same. Then we also use the sum of the voltages to compare them, to see if the sum of the voltages was high, then we can say that there's a low load, and if the sum of the voltages is low, then we can say there's a high load, as I explained while we were looking at the graphs. And what else?
The GUI. Do you want to explain about it, or is it okay? Okay.
I think it's okay.
Okay, so yeah, and we just want to mention that we actually used a lot of methods. So the main file is it finishes here, and yeah, we just created a couple of array lists. Then we used a lot of methods to cluster samples using 2 different algorithms. Then you just plot them, plot the graphs, and test our algorithm. And yeah, that's more or less it.
The different classes. We have a class for the main program. We have a class for the UI.
For the graphs.
For the graphs. Each graph is an object of a class.
Yeah, exactly. We have also the distance comparator, which was used also in the exercises. We are using this to to sort our array list using the KNN algorithm, just to identify the smallest distance samples. Yeah, that's pretty much it. So we can see that the program is working nicely, and yeah, and we have all the samples clustered, and also the plots are here as well. But we will need to run it again to just show
to show all of them at the same time.
Yeah, exactly.
The set graph, learning set.
Yeah, and now it's showing the learning set, and now the test set, exactly. Yeah.
So that's it. Thank you very much.
Yeah, thank you.